Hello everyone, and thank you so much, Sri Shankaracharya Institute, group of institutes, for having me here. And I'm extremely glad that world is moving towards data science. And let me also quickly introduce myself. Way back in 2005, when I started my journey working on statistical programming, a lot of my friends were asking me on, hey, why the hell did you choose this? Statistics as a profession? Don't you think you should be choosing computer science or something related to IT? And I tried very hard convincing them that, guys, this is the future. Okay, and anyways, here we are with a big bang on data and data science and data analytics and artificial intelligence. Here is my quick introduction. I happen to be Industrial Revolution 4.0 implementer, chief data scientist and technology advisor on 4 different firms. I am an alumnus of Indian School of Business and IIT with 15 plus years of experience. I started off working with HSBC, then I joined ITC Infotech, then Infosys, and Deloitte was the last company with which I worked as an employee. And I happen to be director of InnoDataTix. I work on the advisory committee of Sixpus, which is a Malaysian firm. I happen to be a chief data scientist on Brontobet Analytics and Athena Technologies. Alongside that, I'm director of 360 Digit MG as well. Okay, so there are a lot of certificates which I have, ranging from KPMG, DSDM, Six Sigma, Project Management, until Scrum certifications and Tableau certifications. Okay, next important thing that I wish to talk about is the kind of projects and the kind of work that we do. Yeah, even before that, if you feel you might want to connect with me and connecting with me is going to help you in any way, feel free to do so. Here is my LinkedIn profile. So if you feel you want to connect with me and network and see how best it's going to help, sure you can. And there are a few posts which I wish to speak about. And posts. I would sincerely request you all to follow our page and subscribe to our YouTube channel. I'll let you know the reasons. Because we keep conducting monthly one free program on the emerging technologies. People are now speaking about auto AI, auto ML in a very big way. So this is going to be the next big thing, auto ML, auto AI. This means you need zero programming knowledge. With zero programming language, without writing even a single line of code, can you build your algorithm? Sure you can. And that's machine learning on cloud. So this is only for 2 days, but then people can benefit, they can reap benefits out of these kind of sessions. And I would certainly recommend this, wherein all you need to do is go to our page, and this is our page, and you need to basically just apply for this program. That aside, all these kind of events would be posted on our page, company page. So I'm also posting our company page here. I request you all to just, all you need to do is click on that link and follow, and then you get access. Okay, and there we go. We have also built AI-driven robot. If you happen to come to, let me open LinkedIn, otherwise here on this. So when you happen to come to Hyderabad, you should certainly visit our office, and you'll reap the benefits. Okay, I just don't remember my. Ah, yeah, it's coming up, so that's good. It took a while, but it's coming. So this is a robot that we have built, and this robot was built in collaboration with our team of data scientists and our participants. So we also are into edtech business, and when we deliver trainings to our participants, we give them internship opportunities. And yeah, they build robots and bunch of other things. That's our office, Hyderabad office. And we are also trying to come up with Winnie 3.0, which can jump, which can run. That's going to be released in 2021. So every year we come up with a few enhancements to the robot. I also conduct sessions at Indian School of Business. That's one of the courses. And we have written a book on data science. While the free version of this is live, you just need to go to our website, 360digitmg.com. And it is digit mg. That's how we pronounce it. Okay. And we have learning resources here. And in the learning resources, you need to click on download, and you have to provide your credentials, your email ID, etc. And then you'll be able to download. And you can access the online version of it. Though we have 168 pages, the actual book has exceeded 600 pages. Okay, so yep, you can make best use of that. And we have all the concepts which are explained using images, and we ensure to the extent possible, we give you only what is needed. Okay, so from that perspective, I think we are well covered. And if you want to access the book, here we go. Please bookmark this. And I would rather say bookmark this learning resources because it also has mind map, interview questions, etc. And let me share the details here. So there are 3 links in total which I've shared. And one more link I'll share with you all shortly, that link as well. Okay. I don't know why that's popping up. There is an option to disable that. Okay. We also have domain analytics. People from mechanical background, people from electrical background, people from electronics background, they might feel that, you know what, we are not getting into our core subject. We are getting diverted onto something else. That's an incorrect notion to have. Data science is industry agnostic. You can apply to all the industries, all the sectors, and you can apply it to all the domains, right? And as part of this journey, we have come up with domain analytics programs, and we have 56 plus domain analytics programs ranging from financial analytics to life sciences, healthcare analytics, so on and so forth. Okay, and we also have tie-up with UTM and all that. If you want to, in a nutshell, understand on what is data science, then for that purpose, we created, I think, 8 videos to understand in a lucid manner on what is data science project lifecycle all about. If you want to access that, all you need to do is go to our YouTube channel, and here in playlist, we will have data science lifecycle. Where did that go? Here. And when it comes to data science lifecycle, we have 8 different videos. Every video is 2 to 3 minutes long. So quickly, in a nutshell, you'll understand. So I'm directly going to share this. I highly recommend you to watch this. Okay, please also subscribe to our channel and click on the notify icon so that whenever there is any session which happens, you are notified. These are a few things which I request you all to bear in mind. Next. We also have tie-up with a lot of leading companies, and we do a lot of projects. One such project is all about automatic attendance tracking system. Let it, you know, let it complete the buffered part, and then I'm going to explain about this. Here we are living in the world of COVID-19 now, and if you have biometric system to track your attendance, there is a huge risk because you use your finger, right? You use your finger to scan and give your attendance. If everyone keeps doing that, there is a huge risk of spreading COVID. Hence, what we have done is we have come up with AI-driven system wherein we can automate the entire attendance tracking system using facial recognition. So let me do one thing. I think it's always better that I open it here. I'm not sure why I'm unable to open it there. But then, just give me a bit. I think it's getting recorded. So I'll have to, I believe, just pause my screen for a bit. Yeah, sorry. Just give me a minute while I log into another machine so that there are no glitches. Just a minute. I will do that. And yeah, just a moment. Hopefully, you will be able to see the details now. Just give me a bit. And yeah,
Sorry to interrupt you, sir, but you're not audible, I think.
Am I not audible?
You can be a little louder, I suppose.
Oh, is it? Okay. Hello. Am I
Sir, you
audible
are
now?
audible, but we cannot see your screen.
Yeah. I just paused the screen because I was looking at my password which got saved. So that's the reason. Is it visible now? Is my screen visible? Can someone reply?
No. Yes, it is visible now.
Okay. So is it something to do with my internet speed? Let me check. Oh no, I think internet speed is quite good. Okay. If you all are able to see my screen, then I shall proceed further. Yeah, I think internet speed is pretty fast.
Yes, sir, we are able to hear you and see you.
Wonderful.
Yes, we able to.
Yep, wonderful. So let me proceed further. And this is a system that I was speaking about. I think here also that's the same story. Let me check here. Yeah. So you can watch this and then I'll speak more about it. Yeah. So I'll speak more about this. Here we have used image processing and deep learning algorithms to track the attendance automatically. Not just that, it's also going to track the attendance. We also have temperature sensors tagged to it. So these temperature sensors will also identify the body temperature by identifying the various points on your body. It's going to recognize this. And yeah, just a moment. I think someone is calling me. Just a moment. Okay. Yeah. So these are all the various applications, friends, of data science and AI. Fine. So let us get started with CRISP DM. CRISP DM is one of the project management methodologies which is used to handle data science or AI projects end to end. Okay, and here CRISP DM is a methodology from European Union, and CRISP DM stands for Cross-Industry Standard Process for Data Mining. It is from European Union. And the first step of this is understanding the business problem. You need to first understand the business problem. For example, say there is a bank which walks up to you and says that, hey, now that you are data scientists or AI experts, we want you to help us solve this problem. And this is the problem. Significant proportion of customers are defaulting on the loan. That means they are taking the loan, but they are not repaying the loan. If this is the business problem, and if you understand that business problem, you have to record two things. Number one, you need to record business objectives. And number two, you also need to record something else. I'll first record this. Since a lot of customers are defaulting, your objective is to minimize the loan defaulters. Okay. Minimize the loan defaulters. While you try to minimize the loan defaulters using data science or AI concepts, what you do is, say a bank has database of all the historical loans which people have applied for. And they also have the complete repayment history on whether a person has repaid the loan or not, are they paying the loan installment on time or not, all those details. Given the age, gender, loan amount, interest rate, what is the category of the loan, personal loan or commercial loan, all those details, assume you have. And if on this data, you actually end up building a machine learning algorithm. Say you built ML algorithm and you use Python or R or the latest buzzes. And the buzz is around cloud computing. You can use AWS or Azure or GCP, etc. And then say you build this model wherein you want to predict on whether a person will default or not default. Say this is what you are interested in, on whether a person will default or not default. And if a new customer applies for a loan, you might want to predict on whether this new person who has applied for the loan, will that person default or not. Say your prediction says that there is 90% probability that a person will default. Then what do you do? Based on this prediction, what do you do, friends? If someone says that, or if your model says that there is 90% probability that people will default on the loan, then what will you do? Will you approve the loan or will you reject the loan? Yeah, would you approve the loan or would you reject the loan? Can someone use the chat and let me know? Would you approve or reject the loan, friends? What would you do? Hello, am I audible or not? I'm not receiving any response, so I'm a little surprised. Am I audible or not audible? Hello. Hello, can someone please let me know?
Audible, sir?
Audible? Yeah, I mean,
Yes, yes, audible,
absolutely, there
sir.
is pin drop silence, so I'm a little surprised. Okay,
No, no.
so yeah, can
We are
people
listening, sir.
resort to at least chat window and let me know on what would you do if this is the prediction which says there is a 90% probability that someone who has applied for the loan will default. What will you do? Will you approve the loan or reject the loan? Can someone respond, please? Okay. I think you do not want to reply. Not sure why. Okay, anyways. Basically, we reject the loan. If the prediction says that there is going to be 90% probability that someone is going to default, then obviously you're going to reject the loan. Banks usually make profits by lending the loan. So banks lend loan and they make profits. And based on the profits, they run their operations. If you are rejecting the loan, that means you're not even lending the loan. And if you do not even lend loan, then your profitability will come down. Hence, bank would also levy a constraint on you. That's called as business constraint. And the business constraint is as follows. While you're trying to minimize the loan defaulters, can you also maximize the profits? If you can maximize the profits, that is going to be a constraint. Then this business problem will be a very different business problem to handle. It will be a very challenging business problem to handle. Okay, so this is the first and foremost step which you need to understand. And once you understand this business problem, you need to record your objectives and constraints. Record your business objectives and business constraints. Not just that, when you write down your objectives and constraints, you have to always ensure that objectives and constraints are not paragraphs long, but they are only 2 to 3 words long. 2 to 3 words. It should be crisp and clear. And to the extent possible, you need to use terms such as minimize or maximize. These are called as data optimization terms, and it really makes sense to record your business objectives and constraints in this way, so that after you complete your project, you can notify to your stakeholders saying that you have met the objectives for that purpose. And the very first document that you create on your project is called as project charter. This project charter document contains all the various details at a very high level. Okay, when I say high level, you'll have the high level requirements. What if you're building a product, what are the product characteristics? If that's a project, not a product that you're building, then what are the high level project requirements? What are the milestones? In the first 15 days, what would you do? In the next 20 days, what would you do? In that way, you need to have summary milestone schedule. And you also need to have a summary budget. Summary budget means what will be the amount that will be set aside. You'll have the details on the key stakeholders, high level risks, etc., etc. And this document is signed by project sponsor. So that is your first step. Once you're done with this, you proceed further with the next step, which is called as data collection. You need to collect the data in order to solve your business problem. It's not the other way around. You get the data and then decide on how to work. No. You understand the problem and then collect the data. Here, most often than not, Data is very precious, friends. Okay, since data is very precious, you cannot go and ask the customer for entire data. Customer would rather tell you or ask you on what data you want. That would be the question that your customer will ask you. So you have your client, organization, or customer. The company which does the projects, say you have State Bank of India, for instance. State Bank of India is customer, and probably you're building loan default prediction model, and you become performing organization. You become performing organization. Towards the end, I'll let you know on why these things are important that I'm speaking about, right? Because almost all the machine learning algorithms are being automated using auto ML, auto AI concepts, using cloud. Even if people do not know algorithms, if they know at a high level what algorithm has to be applied, job done. And we are not far away. Already organizations have started moving towards that. It's a cost benefit analysis. Rather than hire bunch of data scientists who have done their PhD and who are very well versed with math and programming, you need not pay them crores of rupees. Instead, you take AWS account or Azure account or GCP account, and they will do the job for you. You'll be spending far less amount than what you spend effectively on a PhD. So things are changing rapidly, drastically. So you're called as performing organization, and you'll have team of data scientists. Okay, then when you go and check with the customer on what data they have, customer would obviously ask a question back to you on, you tell me, since you're a data scientist, on what project, what data you need. So you as a data scientist within your organization would be maintaining and should maintain something called as repository, which is called as OPA, organizational process assets. In this, all the historical projects that you have successfully completed, if your projects failed, why did they fail? All these kind of pointers, data, documents, artifacts, etc. would be there. You look at what kind of data you have used in the previous projects. This is if you have already done similar kind of project in the past. What if there is a brand new project? If there is a brand new project that you're working on, then what do? If it's a brand new project that you're working on, then you need to do research, market research, to understand what kind of projects are other people doing. You know what? There is something called as AWS Marketplace. All these kind of projects which were successfully delivered, you can actually sell it. By putting it on AWS Marketplace, you can actually sell it. And there are various other research forums that you can make use of to understand what kind of similar projects different other organizations have done in the past. And there you will come to know on what are the various variables, right? What kind of variables, what was the output variable, what were the various input variables which people have used. All that data would be available. And then you go to your customer saying that, hey, dear customer, 1, 2, 3, 4, these are the variables I need. Do you have those details? Yeah, if those variables are there, then customer would readily give you that. And if the data is already available with your customer, that is called as secondary data source. Secondary data source means data which is already available with your customer. The best part is, since it is already available with the customer, data is easily available. You can just go collect the data from the customer and proceed further with your analysis. The disadvantage is that sometimes important variables might not be there. If you do not have important variables, then what do? For example, we have done a specific project for a US-based educational client who was specialized in education loan. They were specialized in providing education loans. And they asked us to build this model wherein they told, hey, I want you all to predict whether a student will default on the loan or not. And there were multiple inputs, such as age of the student, gender, what was the college they were applying for, what was your percentage in secondary school, multiple such details, what was the specialization, etc. But the disadvantage was that these were the students who were applying for the loan for the very first time in their life. So there is no CIBIL score, there is no credit history, nothing. They don't have any transactions and they are applying for the loan for the very first time. Since they are applying for the loan for the very first time, the variables which were available weren't helpful. We wanted more data, but that data wasn't there with the client, with this educational loan company. So then we resorted to primary data collection mechanism. What did we do? We have actually, back then Facebook was very open. They believed in open data sharing strategy. Democratizing the data was what they believed in, but then they ran into a lot of challenges. So now they've blocked a lot of such channels. And using Facebook, we have extracted details such as how many friends do you have? If someone doesn't have too many friends, is something wrong with this guy? Okay, and we also have done emotion mining. What are the kind of posts or what are the kind of comments the student who has applied for the loan has done in the past on social media? Were the posts related to posts and comments related to some kind of racism, or was it related to some kind of hate speech, or was it a normal thing? Sorry, one second. Okay, so sorry, friends. So sorry about that. So, yeah. You have this primary data source, posts and comments. From this, we started extracting the emotions and we started tracking that also. Not just that, we started looking at, is a specific student spend thrift? Meaning, the moment there is iPhone 12 launched, they might want to quickly purchase one and post on social media that, hey, I have access to the latest of the, latest of the mobile. If someone is spending too much on the latest of the gadgets, would that person even have money to repay the loan? Or would that person be inclined towards repaying the loan? Or would that person divert the money to purchase iPhone? Who knows, right? So all these kind of additional data was included. So alongside the secondary data, that is data which was already available with the bank, we have resorted to primary data source collection mechanism as well. Okay, next. So once you understand the business problem, you need to go collect the data from primary and secondary data sources. And you also should be aware of the various data types. Once this is done, you have to proceed further with the next step. And trust me when I say this, that you will not get data which is extremely clean and which fits your business problems like a team. You would not get such kind of a data in practical work, in real world settings. So what you have to do is, you have to clean your data. And when it comes to cleansing the data, there are a lot of things. like performing outlier analysis, missing value treatment, which is called as imputation, right? Then transformation of the data, discretization, binning, grouping, normalization, standardization, dummy variable creation, typecasting, you name it. And research says, of course, I also say the same thing, but research also says that on this step 1, 2, and 3, typically a data scientist spends 60 to 80% of time. If you spend less than this, that means something would be going wrong. So 60 to 80% of time people spend on these 3 steps. And out of these 3 steps, again, majority of the time would be spent on data cleansing, data preparation, exploratory data analysis, feature engineering, etc. And you cannot clearly delineate or differentiate among these 3 steps that you're seeing here. So you have data cleansing, data preparation, data munging, data wrangling, data organizing, all mean the same. And 3A, 3B, and 3C cannot be differentiated clearly. There'll be a lot of overlapping. Okay. So you also do exploratory data analysis or descriptive statistics. And when you do descriptive statistics, it is as important as predictive analytics. So descriptive analytics is all about business intelligence to a great extent. This includes business intelligence components. That means you just get the data, you create certain visualizations, and job done. And a lot of insights that you draw would come from descriptive analytics, and a lot of actions which your management take, improvement initiatives, etc., would be dependent on insights that you glean from descriptive analytics. Next to this will be predictive analytics. Predictive analytics. What do you do in predictive analytics, right? You do predictions and all that. We'll get there. But this is the initial part. In descriptive analytics, you perform first moment business decision. You do it in this sequence only to the extent possible. First moment business decision, which is also called as measures of central tendency. And within that, you have mean, median, and mode. You write down your inferences at each and every step. Then you perform secondary, second moment business decision, which is also called as measures of dispersion, wherein you have variance, standard deviation, and range. Then you have third moment business decision, which is skewness. Then fourth moment business decision, kurtosis, and then graphical representation. Okay, within this, you perform univariate analysis. Uni means single variable, like histogram, box plot, etc. This histogram is used to understand the shape of the distribution. Can you mute yourself, please? I don't know whether I have that option to mute or not. Someone has unmuted. I think Dr. Vishnu Kumar, please can you mute yourself? Or whoever is the host might want to mute. Whoever is the host, maybe you might want to mute everyone. Dr. Vishnu Kumar, can you please mute yourself? Can someone ask Dr. Vishnu Kumar to mute? Okay. Can, can someone ask, please, Mr. Dr. Vishnu Kumar to the room? Or who is the organizer? You might want. Yeah, thank you. Thank you. Okay. So when it comes to histogram, it will help you understand the shape of the distribution. And you know what? I'll give you a simple example from business perspective on how Netflix benefited a lot from a simple histogram front, right? So if you have the data like this, and if you have all the various movies that are being sold in this way, then you know for a fact that wherever you have a peak, okay, wherever you see a peak, that is where majority of the movies lie. And majority of the people would be interested in watching what kind of movies? Super hit movies, recent releases, etc. Right? And super hit movies, recent releases, blockbuster movies, etc. And if you also venture into this market, there will be too much of competition here. There'll be too much of competition. Everyone will want to venture into the same segment, and eventually there'll be a price war. But here, there was also there is also something called as long tail, a simple histogram, right? And when Netflix actually tried to look at this long tail, they found that here there is not a lot of market, there is not a lot of demand. At the same time, there is very less competition or negligible or zero competition. There was no competition at all. And Netflix thought, okay, let us venture into this segment. And people here wanted to watch mythological movies, black and white movies, movies dated back to 1920s, etc. Documentary movies. And there were no one willing to cater to their needs. When Netflix started catering to their needs, they started charging slightly more amount, some premium. And customers in this segment were willing to pay because there was no other player who was providing such a service. And they set up their shop here. They ventured into this segment. They could, get a very strong foot here. And then they occupied the entire segment. There was monopoly. Then they ventured into this segment and captured the entire segment. A simple histogram, which explains the shape of the distribution, can actually change the shape of your organization as well. Alongside that, you can also identify outliers. That's a secondary purpose. So the values along the long tail might be potential outliers. Okay, not just that, you also have box plot, which is extensively used. When it comes to box plot, the primary purpose is to identify outliers, extreme values. And the secondary purpose is also to understand whether your data are left skewed or right skewed. I have a question for you all here. From practical perspective, practical application perspective. Say you have 1 million records, out of which some 10,000 records turned out to be outliers, meaning extreme values. What would you do with these outliers? Can anyone comment? What would you do with these outliers? Would you delete these outliers? Would you remove it? Or would you do something else? Okay, but even before that, you need to analyze these outliers. You first analyze the outliers and then deal with it. There is a technique called as 3R technique. You can apply that, but nevertheless, that aside, you will analyze. When you analyze, you might want to remove, or you might want to retain it in your analysis, or you might want to rectify if there are any mistakes. But analyzing all 10,000 outliers would need an overkill. Too much of effort will go into it to analyze all these. Hence, there are certain techniques such as Winsorization. Okay, there is something called as Winsorization. What happens in Winsorization is that you give some number, say 5%. What happens is, if this is your box plot, if say this is your minimum value and this is your maximum value, then you try to find out 5th percentile. 5th percentile here, and here 95th percentile, because it's 5%. 100% to this, reduce 100% by 5%. Here also increase 0% by 5%. So 5 and 95%. So 95th percentile. So you have 5th percentile here, and here you have 95th percentile. So all the values which lie here would be forced into 5th percentile. All the values here will be forced into 95th percentile. Okay, here all the values you force into 5th percentile, all the values here you force it into 95th percentile. That's called as Winsorization. So you don't worry about analyzing your outliers. Outliers are gone. Of course, there are trimming techniques and various other techniques, but this is yet another technique that you might want to employ. Okay. And then you do a bivariate plot analysis. Certain things cannot be identified using or by looking at just numbers. You need to visualize. There is no other go. Once this is done, you also perform feature engineering. What do you mean by that? This is very, very important, my dear friends. Extremely important. So let me basically give you an example here. Suppose you want to predict on whether a credit card transaction is fraudulent or not. Okay, whether it is fraud or not fraud. So this is what you want to identify. Then you have various inputs such as time of previous transaction. So you have another input which is place of previous transaction. And say you have third input which is time of current transaction. And say you have place of current transaction. So you have all these details. Now, if you want to build a prediction model and say you're using some logistic regression or something, then you will form an equation like this. Y is equal to beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3 plus beta 4 x4. You get an equation like this. And this equation, which is a machine learning model, captures the relationship between your output variable and input variables. Any machine learning algorithm on the planet does only one thing, friends. It will try to find out the relationship between y and x. It will try to establish a mathematical equation which captures the relationship between your output variable and input variables. That is all it does. Any mathematical equation, not just this. Any mathematical equation on the planet does exactly this. Okay, now. Okay, and then if you're using all of these four inputs as is, then this is going to violate something called as principle of parsimony. What do you mean by principle of parsimony? Principle of parsimony means simplest of the model is the best model. Principle of parsimony or Occam's razor means that simplest of the models are the best models. So, but here you're not building a simple model, you're taking all these inputs. Okay, now, how do you apply your domain knowledge and your expertise? And can you do some addition or subtraction or deletion of these inputs such that these can be reduced to two inputs? Can you do that, please? You might want to take a minute and then solve this using these inputs. Do addition or subtraction or deletion or anything. But can you come up with two variables given these four inputs? Can you come up with two inputs? Yep. Let's see how many of you all will get it right. You might want to post on the chat window your responses. Okay, or you might want to unmute yourself and speak, whatever suits you. But please, can you respond to this? Yeah. Okay. So let me give you the answer in that case. Yeah. Does someone want to give an answer? Okay. So let me give you the answer. If you have place of time of previous transaction, say previous transaction happened somewhere in say the previous transaction happened at 3:15 p.m. and the place was Bilal. And another transaction happened at 3:20 p.m. And this time, say it happened in Hyderabad. When you look at these two, and when you look at the difference between these two, it's 5 minutes, and that's called as time lag from one transaction to another. And if you look at Bilal and Hyderabad, you get to know what is the distance. So simply put, using these four inputs, you have come up with two inputs, which is time lag and distance. So if you use these two and build a model, what happens is output, which is credit card fraud, is equal to beta 1 plus x1, beta 1 x1 plus beta 2 x2. That's how you write it. to a single variable. Can I do that? Yes, certainly we can. Here you need to apply the knowledge of physics that you have. That's velocity. And velocity is equal to yeah, this is extremely simple. And there is no problem at all now. Okay, next. So, you understood about CRISP-DM, initial steps. You understand the business problem. You collect the data. You have primary and secondary data collection mechanism. You clean the data, you perform descriptive analytics, and then you perform feature engineering. Before you venture into data mining or machine learning, there is also some amount of time that you need to spend on mathematical foundations, probability distribution, so on and so forth. All that aside, the next step here is to build your model, machine learning model. When it comes to your data mining or machine learning, within this you have supervised learning, which is called as predictive modeling, and you have unsupervised learning. There is a new field which is emerging, which is called as reinforcement learning. Reinforcement learning is a new field which is emerging. Good or bad. So let's spend some time on this. This consumes at least 20% of your time. Since 60% minimum is spent on these first three steps, this step consumes approximately 20%. Depending on algorithms, but application or the actual time that you spend on those when building your model will be only 20%. And then you evaluate your model and deploy your model in production. Okay. So when it comes to supervised learning or predictive modeling, the one thing that you need to remember is that within your historical data that is provided to you, you will have your output variable and input variables. Say it is lone default prediction model, then you'll have an output variable which says customer 1, did that person default? Customer 2, did that person default? No, that person did not default. Then inputs will be age, gender, income, educational qualification, so on and so forth. If the output Y is known to you, then you proceed further with supervised learning techniques. If the output variable Y is unknown, then you proceed further with unsupervised learning techniques or descriptive modeling. So on one side you have supervised learning, on another side you have unsupervised learning. Okay, so let us spend some time on machine learning primer. That is, how do we go about building a machine learning algorithm in the first place? Step one, you first go get the data. Once the data is given to you, ensure that it's cleansed and all that is done. And once the data is in a clean format, what you do is you take your historical data, wherein you have your output variable and your input, wherein you have your 1 second. Yeah. So you'll have your output variable and your input variables. And say you have some 10,000 observations. What do? You try to split your data now into training data and test data. Why do you need to split the data? Because whenever you build your model, your customer will ask you, what will the customer ask? Hey, I believe you have built a model. How accurate is it? Will it work in real world? Then what will you say? Will you say you go try out in real world and then let me know whether it works or not? Can you say that? No, not really. So what you need to do is, you need to clearly split the data and then build your model on the training data, test it on the test data, and then communicate to the customer that you didn't just build the model, but you have also tested your model for that purpose. And whenever we split the data into training and test, usually we apply random sampling technique. You do a random sampling. Okay, so you randomly sample the data and then you proceed. When you randomly sample, 80% of your data is part of training and another 20% of the data is part of test. So when you randomly split, you will have output variable x1, x2, x3 inputs. And since you're randomly splitting row number 2, row number 4, row 5, row 8, in that way, randomly your rows will get picked up. And when you count all these rows, you'll have 8,000. Why 8,000? 80% of 10,000 is 8,000. And whatever rows are missed out here would be part of your test data. You'll have your output variable and your input variables. Input variables. Row number 1, row number 3, row number 7 in that way. Whatever is not part of this would be part of this. And then when you count it, you'll have 2,000 entries in total, 20% of 10,000. And then you build your model using your training data. When I say you build your model, you are going to establish the mathematical relationship between y and x. So you're going to form or you're going to come up with a mathematical equation which will capture the patterns. The patterns or mathematical relationship between y and x. If a person, say this is all about what should be the loan amount which should be approved. If the age is 32, gender is so much, educational qualification is so much, this much loan amount can be approved. If the age is so much, education is so much, gender is this, then this much loan amount can be approved. In that way, your model is going to learn the patterns, and those patterns will be captured using a mathematical equation such as y is equal to beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x. Using some mathematical relationship, you capture the patterns between y and x. Once you get that model, You test it on the test data. So the equation will be like this: y is equal to beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3. And here you have inputs x1, x2, x3. You can take x1, x2, x3, and when you want to test, right, substitute x1, x2, x3 in this equation. When you substitute in this equation and when you solve it, you get a predicted value. This predicted value is given a notation y hat. Whatever be it, say 50,000, 1 lakh, 50 lakhs, whatever is that loan amount that has to be disbursed. That's the prediction. But when you look at this here, you'll know what was the loan amount, actual loan amount which was disbursed. So that's your actual value. The difference between predicted value and actual value, when you subtract, you get something called as error. Error for this first row. Then go to the second row. Take all these inputs, substitute in this equation, and then you get a predicted value. Subtract it from the actual value, which is here. When you do that, you get error. Go to the third row. Take all the rows, all the values, substitute in this equation, you get the predicted value. Take the actual value and subtract, and then you get error. How many errors will you get? How many errors will you get? Can someone let me know in total? How many errors will we get? 2,000 errors. Once you get all the 2,000 errors, take a simple average of that and call it as average error, mean error. And this mean error is error of test data. So it's testing error. Say you got error as 3%. Now the model that you have built, you also need to test it on the training data. You built a model, right, on the training data. You take this model and test it on the training data itself. That means take your inputs from here, substitute in this equation, and then you get predicted values. Whatever is the predicted value. And take the actual value here and subtract from the actual value. And then you get error. Take the next row, take all these inputs, substitute in this equation, and the moment you substitute, you get predicted value. Subtract it from the actual value that you see here, and then you get the error. In that way, how many error values do you get? 8,000 error values. Say training error happens to be 2%, hypothetically. Now what you do is, you are supposed to compare training error and testing error are small. Error values should be less, obviously, right? So, and one more thing, even before I explain about this comparison. If the error is 2%, what do you think will be the accuracy? If the error is 2%, what do you think will be the accuracy? Please can you use chat window, friends, and respond. If error is going to be 2%, accuracy will be 98%. And when you add accuracy plus error percentage, you get 100%. Accuracy percentage plus error percentage is equal to 100%. Okay, please remember that. Okay, now here. You are supposed to compare training and test error. If training error is small, testing error is also small, and if both of these are close to each other, so if both of these are small and close to each other, this scenario is called as right fit model. This is a right fit. However, if the training error is less and testing error is high, that means it is overfit. It's like by heart questions and answers. Okay, student is going to by heart all the questions and all the answers. If they do that, then it would be overfit, because the moment there is some number which appears in the question, or if the question has a slight change in the question, then they will fumble big time. They'll not be able to answer. So your testing error will actually go up. This scenario is called as overfitting or variance, and when you have overfitting or variance issues, you need to resolve it using something called as regularization techniques. But then, if the training error is high and if the testing error is also high, if both of these are high, then this scenario is called as underfitting or bias. When you are suffering from, when your model is suffering from underfitting or bias, you need to get more data into your training. Instead of 10,000, you need maybe 20,000, maybe 30,000. Okay. Okay. So you have under overfitting or variance, which is regularization. Underfitting or bias is another problem. You get more data and solve this problem. Underfitting or bias is a smaller problem. Overfitting or variance is a bigger problem. Okay. So you always need to aim to get a right fit. Underfit or overfit are certainly problems. Okay. And here we calculated errors. Right? For if your output variable is continuous, let me go here. If your output variable happens to be continuous, then you can calculate the errors using any of these formulae. Mean error or mean absolute deviation or mean squared error or root mean squared error or mean percentage error or mean absolute percentage error or correlation, anything can be applied. But if your output variable is discrete, you go with confusion matrix or cross table or contingency table. All three mean the same. If your output variable is discrete, this is what we do. Okay, and Error functions are also called as cost functions or loss functions. These are the different names which are given to error functions. Of course, there is thin line of difference. Without delving deep into that, error functions are also called as cost or loss functions. And within data mining or machine learning, in supervised learning, which is also called as predictive modeling, you have regression models, simple regression, multiple linear regression, non-linear regression techniques, logistic regression, multiple logistic regression, multinomial regression, ordinal regression, Poisson, negative binomials, excessive zeros, etc., etc. The beauty with respect to regression models is that you can interpret the results. You know what the results mean. For instance, say you're trying to predict mileage of a vehicle, which is equal to some 12.6 minus 1.3 into weight, right? Minus 1.6 into top speed of a vehicle, so on and so forth. What do you mean by minus 1.3? This means that if you increase weight of a vehicle by 1 unit, 1 kg or 1 pound or 1 ton, if you increase weight by 1 unit, mileage of a vehicle will decrease by a factor of 1.3. All else being equal. All else being equal, mileage will get reduced by a factor of 1.3. This kind of interpretation exists, and hence people are still resorting to regression models. But the disadvantage is that you need to do manual feature engineering. I explained, right? If you have 4 variables, time of previous transaction, place of previous transaction, time of current transaction, place of current transaction, in that way, you do feature engineering and come up with a new variable called velocity. That's manual way of dealing. You know, that's the disadvantage. And you avoid overfitting using shrinkage methods, and you have subset selection techniques which exist. And then you have classification models. Classification means will a patient have COVID positive or not? It is categorical classification. Will a person default or not? Will a person claim insurance policy or not? Will a customer churn or not? Will an employee treat or not? All these are examples of classification models. And when it comes to classification models, you have K nearest neighbor technique, naive Bayes technique. In divide and conquer, you have decision tree C5.0. Then you have black box techniques, in which you have support vector machine, neural network algorithm. And the beauty with respect to the support vector machine, or rather neural network, is that, or both for that case, they will be able to perform automatic feature engineering. Feature engineering can be automatically performed. So rather than doing manually like what we have done for regression techniques, here you can automatically do it. And we also have ensemble techniques in a lot of competitions. You must be hearing that, hey, people are winning some awards, you know, their project won the first place, so on and so forth. All those are thanks to your ensemble models. Ensemble models are combination of multiple models. Like rather than taking single doctor's opinion, you go and check with multiple doctors. One doctor says, hey, you're COVID positive. Immediately you go to another doctor and check. That another doctor might say, hey, no, you're not COVID positive. Then you go to a third doctor might say, you're not COVID positive. One doctor might go wrong, but all the doctors won't go wrong. That's called as ensemble technique. It's combination of multiple models. Within that, you have bagging, and a variant of that is called as random forest. Then you have boosting, wherein you have ADA boost, ADA boost, gradient boosting, and extreme gradient boosting. Then you also have something called as stacking. These are your supervised learning tasks. And within your unsupervised learning task, you have something called as clustering or segmentation. If you have group of customers, say you have bunch of HSBC customers. Say HSBC has some, um, you know, 40 million customers. You have all the 40 million customers. And say you want to do an email marketing, or you want to promote your HSBC credit card. And you say that if you buy iPhone 12, you get special 20% discount. Okay, if this is what is a promotion, would you want to send email, and perform email marketing to all these 40 million customers? Would you do that or would you not do that? Yep. Again, I would request your help here in responding to this. Would you do that or would you not do that? I mean, would you like to send an email to all the 40 million customers or not? Obviously, no, right? You don't want to send your email to all the 40 million customers. Why? Because what if you have one of the customers as Sachin Tendulkar, or one of the customer as Donald Trump or Narendra Modi? Do you think they'll be interested in that special 20% discount on iPhone 12? Not really. So you would end up wasting your resources by sending email to all the 40 million customers. So what ideally you need to do is you need to apply segmentation or clustering. You want to group related customers together. Maybe all the, probably you might come up with different segments, 3-4 segments. One segment might be all the tech geeks. Another segment might be all the politicians. A third segment could be all the sports personalities. Fourth could be bridge customers. Fifth could be some other, upper middle class, so on and so forth. Now that you have all these segments or clusters, you need to market or devise marketing strategy accordingly. That's clustering or segmentation. Then you have dimension reduction. If customer gives you 1,000 inputs to work upon, and when you build a model, how would it look like? Y is equal to beta naught plus beta 1 x1 plus beta 2 x2. If you're building a regression model, plus beta 3 x3, in that way, you'll have 1,000 variables. Since you have 1,000 variables, it would mean that you're going to build a very complicated model. Since you're going to end up building a very complicated model, it always makes sense to perform dimension reduction, reduce these 1,000 to only probably 10 inputs. Can you do that? This is not deletion, by the way. This does not mean delete 90 or delete 990 and then keep only 10. No, it doesn't work that way. And then you have association rules, recommendation system, you have network analytics, text mining, so on and so forth. When it comes to network analytics, you deal with graph data. Graph data means if you have flights, aviation, you'll have source, destination, different flights moving from different location to different location, right? In that way, you'll have this data, right? This kind of data is called as graph data. If you want to deal with graph data, you need to proceed further with network analytics. And then you have unstructured data, text mining. When it comes to unstructured data, you'll have videos, images, audio file, and text file. If you want to deal with unstructured data today in the world that we are living in, deep learning algorithms are highly preferred, and deep learning are a part of supervised learning. And also you have deep learning, unsupervised learning techniques, right? Deep learning algorithms. Okay. But usually to deal with videos or images or audio or text, you use deep learning techniques. Of course, there are other traditional techniques which come in very handy. All right. Once you're done with this, once you evaluate your model, and also you're forecasting time series data in which date and time and the sequence in which you arrange the data is important, is called as forecasting or time series data. Within that, you have model-based approaches and data-driven approaches. Okay. And finally, you deploy a model in production. Once you are happy with your model performance, you deploy a model in production. So how do you deploy? Let me briefly give you a couple of examples here. One is called as batch processing. What do you mean by batch processing? Let me explain about that. Oops. Sorry, I accidentally selected that. Okay. One is called as batch processing. And okay, what happens in batch processing is that say you have a loan default prediction model that you built. You'll first of all take the historical data wherein you have information output variable on who are the customers who defaulted, who are the customers who have not defaulted. And you'll have various inputs such as age, gender, income, educational qualification, loan amount, interest amount, what category did they take the money to, for home loan or personal loan or education loan, etc. Once you have all of those details, you build your machine learning algorithm. Once you build your machine learning algorithm, using say Python or R or whatever tool that you have, and nowadays cloud-based solutions are becoming famous. And then you build a prediction model to predict whether a person is going to default on the loan or not. Default or not default. Here, when say there are three customers, customer A, customer B, customer C, who have applied for the loan on a specific day, you will say that, okay, I will collect all these applications, loan applications, and at 6 p.m., we are going to process the data. At 6 p.m., we are going to run these applications through our model. Say you got details such as customer A, there is 80% probability that a person will default. For customer B, it is 10%. Say there is 10% probability that someone will default or B will default. For C, you got 50% probability. Then what do? You take these results, write it back to your database here by creating a new column. And those results, you try to display it on your dashboard. Okay, on this dashboard, your loan officer who has access to this dashboard will see these things such as customer A, 80% probability that this person will default. So would you approve the loan or would you reject the loan? Or maybe you might want to automate this process and say that Any person who has probability greater than 70% will of defaulting, you will automatically reject it. And then for customer B, maybe it says 10% probability. So you might also put an automated condition saying that if the probability of defaulting is less than 20%, you automatically approve the loan. Okay, and for C, it's 50%, so you cannot automatically approve or reject. So maybe you might want to do some additional manual checks. And this is the kind of dashboard which will be visible. This is a typical deployment. This is called as data pipeline or data architecture that you build and then you deploy. This is batch processing. Sometimes you also might want to have real-time processing. What do you mean by real-time processing? If instead of loan default or not, if it is credit card transaction, okay, say you have credit card transaction, such as if you have a database with list of all the credit card transactions which have been performed until now, and in certain cases, credit card transactions might be fraudulent, fraud or not. So you take this historical data, you build your machine learning algorithm. Again, you use some tool, R or Python, some statistical tool, and then you classify on whether a credit card transaction is fraud or not fraud. Okay. Here, you cannot say that you are going to take all the credit card transactions which happen on a specific day and you're going to process all of that at one point of time. Doesn't help. Because to identify credit card fraud, you have to instantly do it. You have to real time do it. As and how a specific credit card transaction goes through, you have to immediately classify on whether a transaction is fraudulent or not. Say you get 90% probability that a credit card transaction is fraudulent. Immediately write back those results to your database and display those on the dashboard. Your fraud analytics team would look at this dashboard, and if it says that, hey, this transaction, there's 90% probability that this is fraud, then instantly, immediately, you basically predict. Yeah. Instantly you predict that that's a fraud transaction, and this fraud analytics team person would immediately call this customer and check, hey customer, did you do the transaction? Oh yeah, I've done it. Then they will approve. No, I've not done it. Then reject it. So that's typical pipeline building, architecture building, and that is how you deploy your machine learning model that you built in production. Of course, future belongs to cloud, because on cloud, you need not worry about parallel processing, what hardware do I need to use, what should be the server speed. You need not worry about all that. Okay, so that's typical crisp DM. So let me do a quick recap and then I'll be open to take questions from you all. So you need to be aware of project management methodology to handle data mining projects. One such famous and most successful project management methodology is CRISP-DM, which stands for Cross-Industry Standard Process for Data Mining. You need to understand the business problem, collect the data, clean the data, build your model, evaluate the model performance, and finally you deploy your model in production. And you keep monitoring your model on how your model is actually performing. So that's that's it from my side. If you have any questions, please ask me. So I'll wait for a couple of minutes to take your questions. Do you have any questions?
Participants, are you having any question? So you can continue,
Okay.
I think. No
Yeah,
worries.
I'm done, ma'am. I'm done with this.
Okay,
And
okay,
yeah, if there are any questions, they can ask me. If not, then yep. Thank you. Thank you so
okay,
much.
okay, okay. So,
Sorry.
so this is all from your end? So I would like to thank you, Bharani Kumar sir. Thank you very much, sir, for your nice session.
Thank you.
Thank you
ma'am.
very much.
Thank you so much.
Thank you, sir. Bharani Kumar left. So participants, thank you one and all. We will be meeting for a tomorrow's session. The next session, tomorrow's session will be starting at 10:15. It will be by Professor Subhajit from IIT Bhilai. So I hope everybody will be joining within time. So we'll meet tomorrow at 10:15 sharp. Okay, bye. Thank you. Thank you one and all.
Thank you, ma'am.
Thank you. Thank you.
Thank you very much, ma'am.